See that red dot means it's on. And then it'll turn off. You okay? Okay, good. So anybody here back here, tell me when that red dot goes off, okay? Anyway, we're going to try this out. Let's see how it works. Right, we're going to make this because we're going to talk about what's called U substitution for integration. And unfortunately, again, since we're going to be recording this, I'm going to have to use this one portion of the board. You know, hope your markers will cooperate. But anyway, let's try this out. We don't seem to be on mute. Okay. Well, just to let you guys know where this comes from. Okay, this actually comes from, believe it or not, chain rule for differentiation. In other words, if you guys remember, we had to differentiate a function in a what? Function. Do you guys remember this? And we had to identify the inside function. So this was our inside function. And if you remember from chain rule, this turned out to be f prime of g of x times what? G prime x. And that was from chain rule. Okay, you guys okay with that? So, if you take a closer look at this, what this actually means is, let's stop and think about it. Let's call this little w, and let's call this big what? Big W. So does anybody know, why am I going to call it little w and big W? In other words, what do we know about antiderivatives? Right? This implies, doesn't this imply then, that the antiderivative of little w, your antiderivative of this expression here, is really what? This. Is that true? So what that means is, if I integrate anything that looks like this, okay, if I integrate anything that looks like this, its antiderivative or integral is actually this. So you get your f of g of x plus my what? Plus my c. Okay, this is what we call U substitution, but you're going to say to me, well, where's the U? There's no U here. Is that right? Do you guys see a U anywhere? No. Did you guys see a U before with chain rule? What was U with chain rule? Yeah, it was the inside function. This was your U, right? That's right. So U is the inside function. You okay with that? So we're going to let now U be g of x. It is the inside function. So I know that this is U and this is what? U. Okay, you guys okay with that? But then the real question starts to become, if this is U, it's my g function, the inside function. Here's my U. I can replace my U there. What is this portion then going to be? We need to know what this is. Right? This is now going to be, believe it or not, f prime, integral of f prime u. But what is g prime x dx? Well, if u is g of x, tell me if you guys agree with this. I'll put it in blue. That isn't it true that du dx, is that g prime x? What do you guys think? Is that g prime x? Say yes. I'm differentiating u. It's a function of g. So du dx is g prime x. Now, what this also means, if I multiply both sides by dx, right, isn't this a differential? So what we get is that du is really g prime x, what? Dx. So this g prime x dx is actually what? Du. And that makes a lot of sense here, because you say, why does that make some sense? Because if I'm going to integrate some function of u, it has to be with respect to what variable? U. Is that right? So let me put this all together, because this is what we're going to use. Let's put it up here. What you're looking at is this. You have this expression here so far. I'll put it here. We're going to integrate f prime of, let's see, g of x, and then I have g prime x dx. This is what's really going on. This integral is the same as, let me plug in my u and my du, right? If I let this be u, then this integral is the same as f prime of, let's put this in red, u. Okay, and what's g prime x dx? Put that in blue. This is what? Du. And this will equal, ladies and gentlemen, what does this equal? F of what? F of u. Plus your what? Plus your c. Okay? So this is actually what's called u substitution that I have. If I have an integral that looks like this, then it's equal to f prime u du, which is really going to be, notice this is f prime. Isn't this the antiderivative of f prime? So this is the antiderivative of f prime. It's with respect to the variable u. And then finally, we're going to use the relationship, just to go all the way, that this is really f of g of what? X plus c. So maybe I should do this. I'm going to erase all this stuff because, like I said, we're going to be limited to one board today. And, you know, anyway, anybody have any questions on this sort of explanation of where it comes from? Okay, it comes from what? Chain rule. So u substitution is really, you know, in some ways analogous to chain rule for derivatives. Okay, so I'm going to erase this here, but we're going to use it. Okay, anyway, let's get rid of this. So this is my u substitution format. Maybe it's better to put it right here so we remember how to use this, because it's kind of long, is that right? So it's kind of long. I'll explain this to you guys. Here is f prime of g of x, g prime x dx. That's going to be the integral of f prime, let's keep that in red for us for now, right, of u, because that's what we have to focus on is the inside function. And then we'll have du. Now, we know that equals f of u plus c, and where what? Where u is equal to g of x. So let's erase this. Plus your c. So, like we said, notice this is the sort of reverse of chain rule. But remember, I also said in some ways, it's kind of like, remember, we don't have a product rule for integration. There's no product rule. But this kind of behaves like a what? Product rule. And you say, well, what do you mean it behaves like a product rule? Well, let me give you an example here. Remember, u is g of x, and du is g prime x dx. So let's give you an example of what we're talking about here. Let's integrate here, for example. Let's say, oh, what is this? Let's keep it simple. Let's say this is cosine x cubed times 3x squared dx. Okay? So notice this is kind of like a what? Product, right? There's a product here, isn't there? Okay? This is one function that's composed of maybe a product of two functions. Looks like that, right? This is a product of two functions. I make the claim that you can integrate this by using what? U substitution. And you say, well, what are you talking about? And that's the thing. All of these problems are very specially chosen. They're very specially chosen so that you can integrate by what? By U substitution. Okay, you guys okay with that? So remember this, they're specially chosen so you could use this process because this is a highly specific criteria. Okay, and so here's what you have to do. What do you guys remember from chain rule? Was there an inside function in chain rule? So if you look at this, what do you think would be that inside function? Just like from chain rule. Well, what's the inside? Remember, this is composition of functions. X to the third. This is my what? That's my u. So what you guys are going to do is you're going to let u be x to the third power. Okay? Just like in chain rule. This is the inside function. So u is x to the third power. Okay, you guys okay with that? And then, if u is x to the third power, what's the relationship between u and x? How do I find now du dx? What you do is take the derivative of u with respect to x, and what's this derivative? Isn't that 3x squared? Now, I don't need du dx. What I need is d what? Du. So how do I find du? Do you guys know how I find du? Multiply both sides by dx, or in other words, just simply solve for du. I'm solving for this. Okay, so let's solve for du. When I do that, I get du equals 3x squared what? Dx. So I have to find du dx just so I can get du. So now take a look. Can I erase this? You guys have that? You can't see that? Okay. You should sit over here. You guys are missing the best spots of the house. There's 4 good seats. You're not in the camera view, I think. If you were, let's check. Is that blurry? Remember, that red light has to be on, right? Okay. Here we go. So let's erase this. You're okay? All right. All right, good. Now we're going to put this together. Okay, like I said, today we got a little bit of interesting. We got to write it all up here. We're going to use one portion of the board. It's going to be tough. This equals. Now, would you ever guess that this product is really what? This is now the integral of what? Of what? Cosine what? Cosine of not x cubed, but what? Of u. And what is 3x squared, by the way? In fact, if you take a closer look at all this, what is 3x squared dx? In other words, what is this? Is that du? So this here is d what? Du. Can you guys integrate cosine u du? The answer is what? Yes. In other words, you took this problem that looked like a product, and it's not, well, it is a product, but you took this function here, which is a product of 2 other functions. It was really disguised as what? F prime of that u times g prime. In other words, it was really what you guys see right in here, right? It was really this. So what that suggests to you, and what you should think of, is that this process is very, very what? Specific. It only works for certain situations. It doesn't work for everything you see in your life. So they're going to be very specific, or variations of it, and you have to learn the process of what's called U substitution. U substitution, you can integrate a lot of things now. Okay, so you can't integrate everything you see in your life. You got to take Calculus 2 to learn more integration techniques, because integrating is a lot more complicated, believe it or not, than differentiating. Okay, going in reverse is a lot more tricky. So I just want to kind of just start you off with that idea that you can't just integrate anything you see in your life. Okay, if I just change a variable or add something different, then that might not be something you could use U substitution with. So these are all very specific so that you get this scenario, which is really what? That scenario. And now, as you guys can see, we can integrate this. What's integral of cosine U? Right, we're right here now, right? Here's maybe 1, 2, 3. We're at step 3 now. What is step 3? What's the integral of cosine U? What is it? Sine U plus what? Plus C. Here's my sine U plus C. But notice, we had to integrate a function of what? Of x. This answer is a function of U. How do you finish this process? What was U to begin with? X cubed. So you're going to plug back in here an x what? Cubed. So that your final answer here for this problem is actually sine of what? X cubed plus C. Okay, so let me just give you a quick check about this. Remember, what are we saying here? We're saying that this function here, okay, and this function are related how? What did we just find? Didn't we just find the antiderivative? What does that mean? Doesn't that mean if I differentiate sine of x cubed, what do you get if I differentiate? Isn't that big F, or the antiderivative function? In my demonstration, we call that W, right? So what happens if I differentiate sine? What do I get? Isn't that cosine x cubed? By chain rule, what's that? 3x squared. And, oh, sorry, I forgot to differentiate my constant, but you guys know, what's the derivative of a constant? Right? Derivative of sum is sum of derivatives. So the derivative of your constant is going to be 0, right? So it would be plus 0. Is that the same as you see here? Okay, so this process is very specific. It's called U substitution. And, and that is, we're going to do a lot of these problems by U substitution because it's a big deal in integration. It's probably your major technique of integration in Calculus 1, okay, is U substitution is the big thing. So the reason we want to record it is because when I get Calculus 2 students that show up, if they don't remember U substitution or there's some issue with them in U substitution, they can actually watch the video and go through this and, come up to speed because U substitution, people who aren't in Calculus 2 are going to stop and show you the technique. Okay, they're just going to say, they assume you could do U substitution. But does anybody have any questions on this so far? This is where it comes from. This is a what? Looks like it's a product, and it will be. It's not a product rule, though. There is no product rule. But it looks like it, but it's not. Okay, it's the reverse of chain rule. Let's do some more examples here. Okay, can I erase this here? You guys have it? Okay, take a... All right, let's take a look here. Let's give you a different example with this. We first go through a lot of time to explain it, then you'll do a lot more examples. How about something like this? I'm going to change it up on you a little bit and say, what if they gave us 2x plus 7 to the 5th power times actually 2 dx. And I have to integrate this. Okay, we're going to use again U substitution. But remember, for U substitution, like chain rule, we need to know what the inside function, because that's our inside function. So what's the inside function in this problem? Good. So we're going to let u be 2x plus what? 7. We say let u be this. Do you want to go over here so you can see? Okay. Let u be 2x plus 7. Right? Maybe some of you guys are those 4 of you in the corner here. Anyway. All right. What do you get now after you have u is 2x plus 7? What do you guys need again? We need du dx. And what's that derivative of u with respect to x? 2. What does that mean? Does that mean du is 2 what? 2 dx. Okay, and so this integral becomes, if you want to look at it that way, by doing my u substitution, I'm going to replace 2x plus 7 with what letter? Is that u? So I got u now to the what? To the 5th power. And then, what do you guys notice? What is this? 2 what? 2 dx? What's 2 dx? It's du. Is that right? So I'm going to replace my 2 dx. This is u again. This here is going to be simply what? Du. This is now du. So what do you get now here? If I integrate u to the 5th power, du. Anybody know? Well, what's the integral of, what do I use? Power rule? What does that give you? 1/6 u to the 6 plus what? Plus c. This is my answer. But it's my answer in terms of u. What really is u? 2x plus 7. So your final answer is going to be here. 1/6 2x plus 7 to the 6th power plus my what? Plus my c. And there you go. Now, notice, if I differentiate this function, I'm going to get what? This original function. Okay, you guys okay with this one? Let me get out of the way so you guys could look at it and absorb it. Anybody have any questions on this, how we got our answer? Yes?
How did you get du over dx equals 2?
I differentiated u with respect to x. The derivative of 2x plus 7 is what? It's 2. Okay, you guys okay with that? Isn't it nice and beautiful that they were thoughtful by putting the 2 dx? Weren't they really thoughtful? Oh my God, these guys are so thoughtful. I'm serious, you can't do that. You know, what if it wasn't there? If you start putting, if I put 2x cubed into the 4th power, I may not be able, I can't necessarily use the u substitution. That's what I'm saying, they're very specially chosen. Can I erase this? Need more camera, okay. And then I'm going to kind of modify this a little bit on you. Just a little bit. Okay, let's kick it up and modify it. Because in all honesty, they can give you now the integral of, let's say, square root of, how about 4x minus 1 dx. And I'm sorry, they're going to put here, let's put 4x squared. How's that? Let's make it challenging. 4x squared minus 1. Okay, so they're going to put 8x square root 4x squared minus 1 dx. So I'm going to make it slightly challenging on you guys. Could you tell me now for this problem, what's your u? What's u going to be? Remember, u is always the what? Your inside function from chain rule, if you guys remember. So you're kind of ignoring this, right? You're finding the inside function. The inside function is 4x squared minus 1. You're right, this is your u. Okay? It's the composition of functions again. Now, once I have u, let's ask you, what's du dx? What's du dx? It's 8x. How do you know?
The derivative of a constant in general.
Well, no, the derivative of u with respect to x is what? Isn't du dx 8x? And then what do you do next? Solve for what? Du by multiplying both sides by dx. You now get du is 8x dx. Now, this is what I'm saying here. When you integrate this, I have the square root of u here. And then, what do you guys notice? My du, which would go back here, is a product 8x dx. So I got dx here, but my 8x is missing. It's not next to my dx, right? Is that a problem? The previous examples, didn't I have that, wasn't this, you can't now just say this dx is du. This dx is not du. Do you guys know why? Because dx times 8x is du. This product is du, so I can't just replace this with what? Du. Or can I? What am I saying, really? Do you guys see an 8x over here? Do you guys know the order in which you multiply things doesn't what? Does not matter? Do you guys know that? The order in which you multiply it doesn't even matter. So this problem I can rewrite as what? You don't necessarily need to do that, but I can rewrite this, if it made me feel better, as a square root of your 4x squared minus 1 times that 8x dx, where this is u now, and oh, what is 8x dx? This is your du. So now I have the integral here of u to the 1/2, that's the square root of u, right, times du. Could you guys integrate that? Yes. What is that? That's 1 over 2 u to the what? To the 1/2. Is that true? Oh, sorry. I'm thinking. Sorry, I'm not awake yet. I'm thinking of u to the minus 1/2 power. Sorry, I'll give you that one next. So what is it? U to the what? What's 1/2 plus 1? 3/2 over 3/2 plus my c. We're out of board space today. We're using only one board. So let's put it up here, okay? Now, what do you guys know this means, really? If I'm dividing by a fraction, that's really 2 what? Thirds u to the what? 3/2 plus c. Where does u again? 4x squared minus 1. So this is 2/3 times 4x squared minus 1 to the 3/2 plus c. And in some sense you're done. However, if you actually did a little bit of algebra, what do you guys know about 3/2? I'll let you guys think about this. Isn't that 2/3 4x squared minus 1 times square root 4x squared minus 1 plus c, if you simplified the radical there? Because this is cubed, and you're taking the square root because it's divided by 2 here. In other words, you simplified this radical. Okay? And so notice, we actually did what? We integrated this. So what I'm saying to you, really what happens most of the time, is they really aren't as thoughtful as you think. They're not going to necessarily put the 8x next to the dx. Okay, here's my point. They're not going to put the 8x necessarily next to the dx. Most of the time, they're going to put the 8x where? Out here all the time. So they're just not as what? Thoughtful. Okay, you guys okay with that? Is that easy or hard? Is that easy? Okay. Anybody have any questions on this? I'll get out of the way. Questions? You okay with that? You sure? All right, here we go. Remember, I'm going to test you on this. Let's see what you guys think about this so far. Okay, let's try this example here. Let's try this, okay? Well, what's the inside function? Isn't u pi x? So you're going to let u be pi x. If u is pi x, let's differentiate u now with respect to what? X. What's this going to be? Is that pi? Okay, so I get pi. Let's solve for what? Du, and then what do you really get? Du is what? Pi what? Dx. And so if you guys notice that this integral will become, I got my, what? I got my secant squared of u now here. And notice I got this, what? Pi dx business. What am I going to do here? I'm going to switch the what? The order. Is that right? And now that gives me pi what? Pi du. Because pi dx, here's my dx, here's my pi, is really what? Du. You okay with that? So what you're looking at is now the integral of secant. Oh, sorry. The pi's gone. Sorry. I really got du. I'm actually thinking of something else, but you'll see in the next example. So I'm going to integrate secant squared u du. What happens now? What's the integral of secant squared? Is that tangent? So this becomes tangent u. Okay, plus your c. What is u going to be again? Pi x. So your final answer is going to be tangent what? Pi x plus c. And you're what? And you're done. Okay, so I'll get out of the way. Anybody have any questions on this one? You sure? Yes.
Probably may need a little more explanation on the du part, like so.
On the du?
Yeah.
Well, this here is what? Is du. Okay, if I have u as a function of x here, if I differentiate u with respect to x, isn't that by notation du dx? And that's going to be what? Pi. So notice this. If I'm going to substitute u here, and I have to integrate, okay, this is now not a function of x. It's now a function of what? Of u. And you're not going to be able to integrate this function of u unless you have what here? A du. You can't integrate it if it's a dx. So right now, you have what? Dx there if I substitute u. Now, the good news is that the product of pi and dx, the product of pi and dx is the same as what? Du. So I am free to replace my product of pi dx here, right? This 2, this 2. I can replace it with what? Du. Here's my du. Now I can integrate with respect to what variable? U. So this here, like you did on your homework, you notice that they gave you different letters to integrate? Right? They maybe gave a T and a DT. They get maybe an S and a DS, or an A and a DA. Well, that's integration with respect to that variable. So you got now an ability to integrate secant squared u, but this has to be du. Now, what's the integral of secant squared? It's tangent. This answer is actually tangent u, because you haven't put back what u really is. What is really u? Pi x. Now, what I'm going to say to you is going to sound extremely strange. I'm going to show you how I actually do the process. I really don't do the process this way. The reason we show it to you this way is so that you can see, here's my function and here's du. That's why we show it to you this way. And we show it to you this way initially where the world works out really beautiful and nice. But you guys know the world isn't really beautiful and what? And nice. Well, I'm sorry, you guys are young college students. You still think the world is beautiful and nice. It isn't. Let me show you what I'm going to do this problem again. All right, let me change it a little bit. Let's see if I change it. Secant squared pi x. What if they gave us secant squared pi x dx? I have to integrate this. There's no pi constant here. Okay? I'm going to show you really how you do this, I guess. There's another way to show people how to do this. What would you guys do again? What's your inside function? Pi x. Okay, so you're going to let u be pi x. So u is pi x. What do we find again? We know du. dx is pi, which means du is pi what? dx. Let's go about it the way we've been doing it. And so you're going to say to me, oh, I have to integrate now. Instead of secant squared pi x, I integrate secant squared u. Now there's a dx here. There's a problem. Is that true? Does anyone want to tell me what the problem is? Yes. You see this dx? I can't integrate with respect to u if this is a dx. There's no pi du. I'm sorry. There's no pi dx. I need a pi dx, don't I? And there is none. There's a couple of ways we could do it. I can think of two ways. I just thought of one right now that I never did in my life. But here's pi dx. And that's du. This is just what? Dx. So there's three ways I can think of it. Well, what could I do? Anybody know? What do you really do then?
Can't you solve for dx now?
Yes. Just solve for what? Dx. Solve for dx. So the solution to this problem is this. We're going to solve for dx. You're right. You go, why would I solve for dx? Well, if du is pi dx, what is dx? Isn't dx going to be, how do I solve for dx? I'm going to divide both sides by pi. If I divide both sides by pi, doesn't it cancel here and here? And what do I get? Du over what? Over pi. Why did I solve for dx? Because I could now replace this dx with du over what? Over pi, and our red is gone. So this integral is really secant squared u du over pi. What is pi anyway? Isn't that a constant? Don't I pull out my constants? So this becomes 1 over pi integral secant squared u du. Can you integrate secant squared u du? Or in other words, what's the antiderivative of secant squared? Good, but don't forget, what is there here? Do you guys see what this constant is there. So you're going to have 1 over pi tangent u plus your c, but what is u again? Pi x. So here is 1 over pi tangent of what? Pi x plus c. So, to make a long story short, in all honesty, what is most often going to happen to you are problems like this. Not the first ones we focused on. The first one we focused on were really nice and served to you warm. They're going to make you actually do what? Do a little bit of algebra. Meaning, don't really solve for what? Du. Don't solve for du like we've been doing. Solve actually for what? Dx. And I'll show you again, this is really what's going on. So the first part of the process, let u be that g function. Let u be the inside function. And then differentiate. But don't solve for du. Solve for what? Dx. You're going to see this forever. Solve for dx. And that's going to be the shortcut, or I should say not the shortcut. That'll make things clearer for you. Okay? So you're going to solve for dx instead, and that's really the bottom line. So let's get some more examples. But before we do that, anybody have any questions on that here? Remember, if you're going to integrate with respect to what? U, you got to have du. You can't have d anything else. So let's see how this works. If you have, for example, here, let's integrate x minus 2. Let's say this is to the 10th power dx. All right, no, let's do it 2 minus x. Okay? 2 minus x to the 10th power dx. What would you guys have done on your homework? If this were a homework question yesterday or last night or whenever, what would you guys have done here? You would have to use FOIL or expand this. What's the power here? 10th. How does that expansion feel? You don't like 10? All right. Do 30. You don't like 30? Do 3 what? 300. What I'm going to show you doesn't matter. It doesn't matter what the power is. Okay? The power doesn't even matter here. You say, why is that? Because what's your inside function again? If this were chain rule, what's the inside function? This is my inside. So I'm going to let u be 2 minus x. If u is 2 minus x, what do we need to find again? Du dx. Is that right? So what is du dx? What's the derivative of 2 minus x? Negative what? 1. You guys okay with this? So I let u be 2 minus x. That's the inside function. Find du dx. It's negative 1. What happens now? Do you solve for du or do you solve for what? I'm going to put it in red. Solve always again for what? Solve for dx, not du. I'm going to solve for this. This is going to make everything turn out nice. So if I solve for dx, you guys know what that gives me? That dx really is negative d what? U. Isn't that, if I multiply both sides by what? Dx. Don't you end up getting du is negative dx if I multiply both sides? Because that's negative 1. Is that right? Du is negative dx. And then how do I get dx? Divide by negative 1. These negatives cancel, so I get what? Dx is negative du. So I'm just going to use these two things. I'm going to use this always, and I'm going to use this always. So here's how we use it. We already know if this is u, I'm really looking at u to the what? U to the 300th power. Is that right? Is that true? You guys want it in red? I'm using 3 to the, this is my u. Same u. Now, what do I replace dx with? Dx is what? Negative du. I'm going to replace this with a negative du. Now, what is a negative du, by the way? Do you guys know what a negative du actually is? It's negative 1 times du. Isn't that what you got when you, well, you divide it or multiply it? Okay, negative 1. You could say here, just multiply both by negative 1 as well. Or divide by negative 1. The point is that's a product of negative 1. What can I do with the constant negative 1? I can pull out my constant. So let's pull it out. And you now have u to the 300th power d what? Can you integrate u to the 300th with respect to u if we have a du? Yes. What do you use? What do you use here? It's called what? Power rule for integration. Is that true? Did you guys notice how it doesn't matter what the power is? So what do you get? What is this? Negative u to the 301 over 301 plus c. We add 1 to the power, which makes it 301, and divide by 301. And then this gives you negative. What is u? We integrated, but the function was x. But what is u again? 2 minus x. So this is negative 2 minus x to the 301st power over 301 plus my what? Plus my c. Yes?
When you take out the constant, it only applies to whatever, the x, not the c, right?
Well, there is no constant here yet. It's until you take the antiderivative and then you add your constant. Okay, there's your final answer. Now, would you rather expand that? Just use the binomial theorem. Or use FOIL. That would have taken you maybe a week. Now, I could do this literally in under a what? Minute. You can do this in 30 seconds by u substitution. See, and that's the power of what? U substitution. Okay, they help you do a lot of problems. They help you, shorten, your task time if you want to think of it that way. This is designed to help you and not hurt you. But this is the real process now. Don't solve for du, solve for dx, and substitute that dx here always to get your du. Okay, can I erase this? You guys have that in your notes? So now that you know this process, let's do another problem, and then I'm going to have you guys try some examples on your own. Aren't you guys glad you came today? You imagine if you're not here? Woo! Well, you could read it. It's in your book. You guys know it's in your book. Can I erase this too? You have it already in your notes? Can I erase that? All right. Anyway. Let's do some examples here. Should you find an easy one or a hard one? Huh? You want a hard one? Oh, see if you're awake. Sine square root of x, square root of x, dx. Let's try this out. Okay, what do you think the inside function might be? Is our red light still on over there? Okay. What do you think that inside function will be? Right? Remember, this is composition of functions. Do you see any function inside of another? What do you see? Square root of x inside of the sine curve, right? So this is my u. So I'm going to let u be the square root of x. If u is the square root of x, I know this is x to the 1/2. Is that right? What is du? Well, what's the derivative of u with respect to x? Sorry. What's du dx? Anybody want to tell me what that is? Is that 1 over 2 square root of x? Because I differentiate u with respect to x? Is that right? Now what do I do? Solve for what? We're going to solve for dx. How do you guys solve for dx? Anybody know how you solve for dx? I would make a recommendation. Cross multiply maybe. Doesn't that give you 2 square root of x du? Isn't that equal to what? Oh, that equals dx. Wow, we solved for dx, didn't we? We're going to use these 2 pieces of information. So cross multiplication gives us our dx. Okay, let's see what this does. This is going to be now my integral. This is a function of x. It needs to be a function of u now. I have sine u up here. Everybody agree with that? Isn't there sine u up here? And then what's down here? I'm dividing by the square root of x. Is that true? And then what is dx? That is 2 square root of x du. Okay? Take a look. All I did was substitute u here for that square root of x of sine. I kept this as square root of x, and my dx now is actually 2 square root of x du. What do you guys do with the square root of x's? They are what? They're gone. What do you have left? 2, what else? Sine u and what? Du. So what does this give you? I can pull out my constant. I got 2 integral sine u du. That's what I have to integrate. What is the integral of sine? Is that negative cosine? So this is negative 2 cosine u plus c. But we're not integrating with respect to u. We're integrating with respect to x. What is u again? Square root of what? X. So that final answer is going to be negative 2 cosine square root of x plus what? Plus your c. Okay, you guys okay with this? Is that easy or is that hard? Just take a look at that. Just breathe it in or whatever. Use substitution. I could just do this in my sleep. I should leave my bed here and just sleep in till 10. You guys okay with that? Again, I could do it in my sleep because I had a lot of what? Practice. Remember, I think I told you, I think I said to you guys, you know, sometimes you have to do your homework 2 times, 3 times, 4 times, and 5 times. Don't tell anybody. But when it came to chain rule and use substitution, I was in the 4 or 5 time, you know, homework guy. And what does that mean? In fact, in all honesty, I take that back. I wasn't in the 4 or 5. I did it like 3 times. And then I got a little worried. I was memorizing the answers. So you know what I did? I went to another book. I looked up use substitution. And I tried those problems in another book even. By use substitution. Why do you think I did that? Because I didn't know how to do it. So if I didn't know how to do it, you know, there's no magic wand anybody's going to come here. See, this is a dry erase marker. It's not a wand. You know, I can't wave it and all of a sudden what? You got use substitution. There's a lot of work you put in, even if it means doing homework 3, 4, 5 times. That's what it is. And again, after a while, you go, oh my God, all these problems are very specially chosen. I got this nice... You probably thought the square root of x wasn't going to go anywhere. Yes, it is. It canceled. Because these are still specially chosen. Okay? They're specially chosen problems, so this stuff works out. You get to that comfort level only if you do a lot of problems. I don't even think your book gives you enough, personally. If you look at the book that I used, it would give you probably more than twice as much as what you see there. is so if you had 30 integration problems, it would probably give you about, it says 1 to 30 or something. It would probably be 1 to like 75 instead of 30. Why do you think that is? Whoever wrote it knew they probably need to practice a lot of these. So when it came to chain rule and use substitution, learning the process is actually, where you put all that time and energy. I can do it in my sleep now, not because I'm special, but because all the practice. That's all. That is it. Don't let people in this world walk around and they will try to convince you that they're special. I talk with them every day of my life. They want to convince you that they're special. They are not special. They just won't tell you that they have to what? Practice. They pretend they're special. Okay? So you got to practice, and that's all it is. So when you go home tonight, you're going to do some what? Practice like crazy. We wake up early tomorrow, practice more like crazy, and that's how you can do it in your sleep. So let's try another one that may look fun and challenging. Huh? You're not special? Or are you special? Anybody here special? Your mom told you you were special? So you're special because mom said it? Yeah, I've had people tell me things like, oh, I didn't have to do 70, use substitution problems. I only had to do 10. And I can remember for the rest of my life, I only did 10. Think, really? Are you sure about that? Yeah. I don't believe them. Let's see how special you are then. Huh? Yeah, I sit in an office with special people. Well, not everybody's special there. There are some people who are honest and say, well, they're not so special. Others are not so honest. They say they're special. Let's see if you're special. Can you do this problem? On your own? Let's see how special you are. Yeah, this is the fourth power for cosine. What do you guys think? Should I give you guys some time to try this? Okay, let's turn off the camera while they don't see you cry. You guys ready to try this out? How many people are done? How many people? All right. So some people notice that this portion here, what does that mean? This is cosine x to what power? To the fourth power. So what this equals is the integral of cosine x to the what? Fourth power sine x dx. Is that true? Now, if this were chain rule, and I'm not saying it is, it's a very different process, right? You're integrating. But if you focus on these functions, what would you think u would be? U is the inside function. Remember that? It's between the parentheses, I guess, right? So u here is my cosine function. This is my u. Is that true? Now, what do I do now with it? Once I know u, I can find du dx. What is du dx? What's the derivative of cosine? Anybody know what the derivative of cosine is? Minus what? Minus sine. Is that true? What do you do now? Solve for what? You solve for dx. What do you think that means if you solve for dx? That means that dx will be, see if you're awake, isn't it du over negative sine x? Is that true? If you solve for dx, how did you guys solve for dx? If you have to, like me, because I was not special, I had to create what? Proportions and cross what? Multiply. 1 times du minus sine x dx. I had to do the algebra to solve for dx. Now, it was good that I had to do the algebra because, in all honesty, all this is algebra, and it reinforces your algebra skills because they don't go away. Believe me, your use of algebra and trig does not go away. It just doesn't. So that was good I did the algebra. Don't think of it as a bad thing. So now, what do you guys notice? I just replaced my, where's dx? You see this dx right here? I replaced that dx with du over minus what? Sine x. Now, what do I have all together? I have this all together. I got u to the 4th power times sine x times du over minus sine x. What happens with the minus signs? Or, I'm sorry, what happens with the signs, because minus sign, isn't that negative 1 times sine? What happens with your signs? Gone, gone. What's left? That's a constant. Now, where's that constant at? The numerator or denominator? It's a denominator. But because it's negative 1, does it really matter? So it's minus integral u to the 4th what? Du. And when you integrate this, what's the integral of u to the 4th? U to the 5th plus 5 plus c. What is u anyway? What was u? U is cosine. So this is cosine. We replace my u with cosine now. And as a final answer, I get minus what? Cosine x to the 5th power over 5 plus c. If you like, you know, put your answer again with the power of 5 right in this position here between cosine and x. And, you know, you integrated this by u substitution. Yes?
In this case, you could have solved for du also?
Yeah, you could have. You could have. But in all honesty, I mean, if you guys notice, could you have solved for du instead? Yeah. But in all honesty, like I said, I always solve for dx. I don't even at this point care that this can be du or not du. It doesn't even matter because I know you're going to get your appropriate cancellation here. So it doesn't matter. But always solve for the dx now. Okay? Because like I said, most of the time it's not going to work out nice. Okay? You guys okay with that? I'm going to give you some homework. Try these out tonight. We're going to do some more tomorrow. We're going to videotape, again, the whole whatever this is from here on in. So we'll see you guys tomorrow. All right, let's try these out here. Okay, we did use substitution yesterday. So we're going to try some more problems out. Okay, let's take a look at some of these here. So first of all, I'm going to leave this, you know, this is our u substitution. So for example, what's the first one we had to work on? And we're going to integrate, what is that, x over x squared plus 1 to the 3rd power. And that's dx. Anyway, okay, let's get these markers. So we're going to have to use u substitution. So let me ask you, what is your u going to be again? What's u? Right? U is going to be the x squared plus 1. Why do we want u to be that x squared plus 1? Is that in some sense that inside function, right? Composition of functions. It's in your parentheses. This is the inside function, so we're going to start with that. And this is going to be our u, but once you get u, what else do you get? You got to find du dx, right? So du dx is going to be 2x. Is that true? So what comes next after this? You have to solve for what? You solve for your dx now. So when you solve for this, how you do that, again, you could cross multiply. And that gives you, by the way, du is 2x dx, but we haven't solved for dx. We have to now divide both sides by what? By 2x. 2x cancels. So your dx will be du over what? 2x. So we're going to use this, and we're going to use what? This here. Okay, so this is the first part of your u substitution. Now, your integral is going to become, and this is what I'm saying to you, you let u be x squared plus 1, so this is going to be u cubed. Is that right? I still have this x up here, but now I have u cubed. This is the purpose of letting u be x squared plus 1. Don't forget it's being cubed. But then now, what is my dx? Dx is du over what? 2x. So I got du over 2x. So these are problems that are really specially chosen so that what's going to happen? Your x goes away. And so now you have an integral, because this is a 1/2 constant. I can pull that out. You're going to integrate. This is 1 over u cubed du. But then this is also what? 1/2 integral u to the minus 3 du. This is what I have to integrate now by using my power rule. Is that right? So I got to use power rule for integration. And notice, this is u, this is du. Okay, so I can find this by power rule. What's that integral by power rule? Is that u to the what? Minus 2 over minus 2. And then don't forget to plus what? Plus c here. So what you're going to end up with is what this equals is minus 1 over 4 u squared. Is that true? Plus that what? Plus that c. However, this is in terms of u. This answer is in terms of u. What is really u? X squared plus 1. So this integral, and sometimes I say I for integral, is minus 1 over 4 x squared plus 1 squared plus my c, plus my constant. So I'll use I at times for integral. I kind of, I'll use that definitely in a lot of Calculus 2 courses. You'll start to have multiple integrals to work with, and I'll call that one I and I1 and I2 and all these different subscripts. But anyway, here's a indefinite integral, stuff that we worked on yesterday. Right? Does anybody have any questions on this u substitution problem? Now, what did I put up here? We have the definite integral form. Okay, so here's what I want to say to you. You guys have no questions on this one here? So I can erase that, right? Where's the erasers? Behind me? Thank you. All right, so here's what's going to happen now. Right? And there's a couple of ways to go about this. Your indefinite integral has limits. Is that true? So you're going to get a finite value as an answer now. This is not, a general, function. We have some function plus some antiderivative plus a constant anymore. So now we have a definite integral. And what that means is we apply limits here. We got an upper limit and a lower limit. So this function is in terms of what variable? This is what variable again? This is x, right? So your limits apply to the variable x. So this is x is a, x is b. Now, the moment I say, like in this example, if they give limits like 0 and 1, what does this mean? That means the variable x is 0 and the variable x is 1. My lower limit is 0 for x. My upper limit is 1 for the variable x here. So there's a couple of ways to go about this, just so you guys know, with these definite integrals. We said that we're going to let what? U be x squared plus 1 in our integration by parts, right? So what happens is when I convert this integral from a function of x to a function of what? U. This is a function of u now. Okay, you guys see your variable u? I can't apply my limits of x is 0 and x is 1. In other words, my limits change not in terms of the variable x, but in terms of the variable what? U. And the question becomes, well, how do I find those new limits? Well, it's very simple. What do we say u was here? What is always u? U here is that g of x. It's that inside function. Is that right? So how you find these limits is to look for, or to evaluate, this is u is g of, what was the value for x here for the lower limit? 0. And this is u is g of what? What was the value for x in the upper limit? 1. So we have to change these limit values. Yes?
How'd you get the x equal to 1 and x equal to 0?
I made it up. I made it up. It didn't fall out of the sky. I decided let's use 0 and 1. Also, is it integrable? Is this function continuous over the interval 0, 1? So don't just make it up. I'm a professional. I could do it. Okay? It has to be what? Integrable, right? In other words, that function is continuous for what values of x? Actually, for all real numbers. So you can actually use any interval, right? Okay, so remember that. Some of that was on your homework, right? So don't just add numbers like I did, in a sense. But anyway, you guys should know that too, that what? This function is continuous over all real numbers. Okay, and so you're going to put a lower value and a smaller value. You're going to put your a and b here. The point I'm making, though, is you got to convert your limits from what? X to what variable? U via what function? G. So if this is my g, and I say x is 0, right? What do we replace this with? This is 0 squared plus 1. Do you guys know what that means? That the lower limit for x is 0, over here will be the value what? 1. So I can put it here, or I can put it where? There. And similarly, and this happens when x is 0, if x is 1, u becomes what? 1 squared plus 1, our u is 2. So this upper limit of x is 1 corresponds to u is g of 1, or this corresponds to what value? U is what? 2. This is my u values, okay? So these are my new limits. So what we get now is if I apply these limits now, I can apply this where u now is 1 and u is what? 2. Because this is in terms of what? U. Okay, you okay with that? Now, what we get now with this as an answer, I'm going to keep this here, is, well, you guys tell me. What do you guys get? Can I erase this? You guys have it in your notes? What do you get now? Well, this is in terms of u now. Is that right? So in some ways, well, we'll use that notation. This now becomes minus 1 over 4 times 2 squared minus 1 over 4 times 1 squared. Right? And I'm going to plug in my values of u here. This is my upper limit. U is 2. U is 1. So I now get 1 over, oh, what's this? 16 plus 1 over, what's this? 4. You got to know how to add fractions when you take calculus. They have different denominators. What do you guys do? Personally, I multiply top and bottom by 4. So what this gives me is negative 1, okay, over 16 plus what? 4 over 16. What's negative 1 over 16 plus 4 over 16? That's 3 over 16. Okay, remember your c went away. We didn't mention that, but your final answer is going to be 3 over 16. So here's your u substitution. Okay, you guys okay with this? So we know our answer is 3 over 16. Okay, so this is what you're going to have to do. If you have a definite integral, you got to convert even your limits from x to what? To u. Okay, so that's the idea. You got to convert your limits. So your book's going to say this is going to be u equals g of a, and u equals g of what? Of b. Convert your limits to u as well. So does anybody have any questions on this integral here? Right, it's a definite integral. We focus on indefinite so that we can give you some practice, because the assumption again is that you guys can do the what? The arithmetic.
So then indefinite, we never, at the end, ever convert back the u to whatever u was in the form of x.
Say that again. Indefinite, we never convert back to u?
We never
No.
convert the u back to x.
Oh, you always do. Because if you're integrating a function of x, your answer has to be a function of what? X. What was our answer prior?
It was 1 over 4.
Yeah, exactly. See, that was a function of x, right? Now, if what you're saying to me is this, for a definite integral, if what you're saying, for a definite integral, we never convert back to what? Back to x? Well, that depends. Did we convert to x here? Say no. What does that even mean? What he's saying is you converted your limits to u and you applied your limits, right? In terms of the variable u. Is that true? Did we do that? Yeah, we plugged in u as 2 and u as 1, and what do we get? 3 over 16. Is that right? Okay. There's another way you could go about this. And you say to me, well, what do you mean? This is what I think your question really is. Okay? For a definite integral, can I write this function in terms of x? Sure. So this is negative 1 over 4 times not u squared, but what? X squared plus 1, and that was what? Squared. You said plus c. That's in terms of x. Is that true? Well, what limits are you guys going to use to evaluate this now? Right? What are you going to use the u limits that you converted? Are you going to use u is 1 and u is 2 when this is a function of what? X, not u? The answer is what? No. Then what do you use? What do you guys use? You use these. Isn't this the antiderivative? So I'm going to use these limits. X is 0 and x is what? 1. So I use x is 0 for a lower limit. X is 1 for an upper limit. Because isn't that the antiderivative? Okay, you okay with this? Now, do you think you're going to get the same answer? What do you think? Is the answer going to be different, or is it going to be the same? How do we know it's the same? Well, let's see. Let's do the arithmetic. Okay, how do we do this arithmetic? Isn't this going to be, I'm going to run out of space here. Isn't this negative 1 over 4 times x squared plus 1 squared? What is x? Isn't that 1 squared plus 1 what squared? Minus a negative 1 over 4. What is x now? 0. Then that's going to be a 0 squared plus 1 squared, okay? And so what you end up with is negative 1 over 4 times, isn't this, what's this? What's 1 squared plus 1? 2. What's 2 squared? 4 plus 1 over 4 times, what's 0 squared plus 1? Isn't that 1? What's 1 squared? 1. What does this give you? Isn't that negative 1 over 16 plus 1/4? That looks familiar. What's negative 116 plus 1/4? What do we see in the prior problem? That's 3 over what? 16. I know this board is kind of, we only get to use one board when we videotape. But this is 3 over 16. Isn't that the same answer you got before? So, here's what I'm saying. For a definite integral, you have a choice. You can convert your limits to u and apply it to your antiderivative function in terms of u, or you can convert that antiderivative function back in terms of x and use your original limits for what? For x. So the choice is yours. Which is the right choice to make? Doesn't matter. As long you're going to get the same what? answer. Personally, what I do, I don't even want to say this. I think the real approach should be do whatever's easiest. If it's easier for you to apply the limits with u, then go ahead and do so. If it's easier to apply the limits with x, then go ahead and what? Do so. I think it was easier in this example to apply your limits with u, personally. But I'm a little stubborn. I always go back to my x limits for some reason. Okay? It's just sort of, I trained myself to do that. But that's not necessarily a good thing, you know. It's just, that's how I went about it. But I think the real answer is, if the limits for u are nice and easy, use the u limits. No big deal. Okay? So it's a matter of what you want to do with that. Anyway, that's our first example. I went over some explanation in detail. One of the reasons, like I said, we stick with some of the indefinite integrals is that we could do more examples. And, you know, but I do have to show you this. And anyway, let's try these others. Let's see if we could get this out. Can I erase this here? You guys have it? It's in your book. So, anyway, let's try this out. Let's look at example number 2. We could kick these out. We could do them in our sleep, right? Secant, what is this? Tangent dx. Let's go through our procedure. Right? Oh, 2 pi x. Good. Secant 2 pi x. Tangent 2 pi x. So here's what happens, right? What do you think u might be? U is what? 2 pi x. Okay, then what is du? What is du dx? It's 2 pi, is that right? That's the derivative of, remember, pi is a constant. 2 pi is a constant, so that's going to be 2 pi. So how do we get dx? That's du over what? Over 2 pi, is that right? So this integral becomes, notice this, secant u tangent what? U. What's your dx? Du over what? 2 pi. What do I do with this constant? Pull out my constant, 1 over 2 pi, integral secant u, tangent u, this is du. What is the integral of secant tangent? Anybody know? You guys know? What is this? Let's say you don't know. How do you determine that? Let's say you don't know. Do you guys remember? Take derivatives of, probably not sine. What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. What's the derivative of tangent? Secant squared. It's not what it is. Okay, what's the derivative of, oh, what? Secant. Secant what? Oh, there it is. So the antiderivative of secant tangent is really what? Secant. This goes in reverse. So you're going to get here, this is secant u plus c. Now, I didn't go over this detail with you guys yesterday. Let's go over this detail now, since we have some experience under our belt, right? That you may say to me, hey, what happens here? You know, I know how to use the distributive property. And you're right. You get 1 over what? 2 pi secant u plus 1 over 2 pi c. Is that true? Why don't I just use this as an answer? You go, oh, yeah, because what is u? All right, u again is really what? 2 pi x, right? So isn't this going to be my answer? 1 over 2 pi secant 2 pi x plus 1 over 2 pi c. And you look in back of the book, and what's the answer? 1 over 2 pi secant 2 pi x plus c. And you say, how in the world did they get that? I use the distributive property here. Does anybody want to tell me what happened? What's the logic of going from here to here? Do you guys know? What's the logic? Well, here's what's going on. When you multiply 1 over 2 pi, isn't that a constant? So that's a constant times a constant. So what happens is some people, maybe in the beginning when you learn this, will change that to, they'll call that C1 for a constant 1. And then they'll give the final answer as what? You know, C1. And if this is C, we'll call that C1. Or you call that C1, call that C2. It doesn't matter what you call it. They'll put a little subscript for the fact that it's really just a what? Constant. And after you do a lot of problems, they say, you know, since this is a constant anyway, right? We don't have to name it C1 for constant 1. It's a constant. Let's just call it what? Constant. So what I'm saying to you is, if you're multiplying what? Constants together, it's okay at the very end to just say, you know what? You are just a what? Constant. And you just put the generic C. So sometimes students ask that kind of question. What happened to that, you know, multiple of 1 over 2 pi? Well, it's just called a constant. It's just a constant. So that's why, you know, you have your general sort of form of your antiderivative here. And that's why it's just plus C. But you can put C1, C2. You can do that all day long if you want to change it. Okay? And like I said, back in the day, I used to do that too. I was so anal about it. So I put C1, C2 because I want to be accurate. And eventually I got tired of my subscripts and ended up with just saying, okay, whatever, I give up, put a C. Okay? So this is how you actually integrate this, this function. Okay? So in all honesty, this is where we're headed. This is how you do this. Yes?
Would it be wrong if I just put secant over 2 pi? Or do we have to pull out the...
You mean if you put this 2 pi in the denominator?
Yeah.
No. No. That would be fine. He's saying, can I leave it as secant 2 pi x over 2 pi plus the constant? The answer is what? Yes. Yes. Okay. Let's try number 3. Not so what? Bad. Let's see number 3. What do we have there? We're going to integrate dx 2x plus 1 squared. That looks familiar. Did we do that yesterday? Looks a little familiar. Anyway. What do you think u is going to be? 2x plus 1? Okay. If that's the case, what's du? Meaning du dx. 2, what do you solve for? dx. What is dx? u over 2. So this becomes the integral of u squared. Don't I plug in that u here? U squared? Now, what's my dx? du over what? 2. Is that right? What happens with this now? What do you think we put? How does this all work for us? Isn't a 2 a constant? I pull out my constant 1/2 and I integrate. I have du over u squared. And then what does this mean? Well, this is going to be u to the minus 2 du. What do you get now? What's the antiderivative? What's the power rule say here? U to the what? Minus 1 over minus 1 plus my, okay, really it's plus that c, right? What does this mean? It's 1/2 times negative 1 over u plus that c. And I get negative 1 over 2u plus that 1/2 c. This is every detail. What's 1/2 c? Oh, I can call that what? C1, I guess. And what is u? 2x plus 1. So here, my final answer is going to be negative 1 over 2 times 2x plus 1 plus that constant called C1. Here's my final answer. If you don't care about subscripts, you could just leave it as what? C, and that's fine. So double check. Do we do everything okay? Is that right? And that's number 3. Okay, so this is the process we did yesterday. Anybody have any questions on this one? And what did they give you? they gave us some limits, right? What are the limits? X is 0. X is what? X is 2. Is that right? So if I put limit 0, 2 here, what does the lower limit become if x is 0? Do you guys know? If I had to do this definite integral, if x is 0, what does that make it my u here for the lower limit? So this is 1. If you want to say that here, it's 1. And if x is 2, what's this? 2 squared plus 1 is what? This is 5. So which might be easier, to apply it the x value or the u value? In other words, this becomes negative 1 over 2u. Right? Plus a constant c, where u is 1 and u is 5. Would you rather apply the limits with u or the limits with x? I think u looks like it's easier for me. Okay? So let's apply the limits. It looks easier to do because it's just plugging in a single value, right? And what do you get? Negative 1 over 2 times 5 minus negative 1 over 2 times 1. So I get negative 1/10 plus 1/2. What is 1/10 plus 1/2? Anybody know? I actually don't know. I have to multiply by 5 to get my common denominator. That looks like it's 4/10. Negative, is that positive 4/10? So you get a positive 4/10, which reduces to 2 what? 2/5. Good. Anyway. So you have a definite integral form. You converted your x limits to u limits. You applied them, and you're done with your arithmetic. Okay, so anyway, let's look at number 4 now. Yeah, limited board space is never fun. How's number 4 look? Does that look difficult? What does that say? You got 4 minus tangent theta to the 5th power, and then what do you have? Secant squared theta? D theta, okay. So what do you guys want u to be? What should u be? What do you think the inside function might be? 4 minus tangent theta? Is that right? Is it between the parentheses? It's a composition, u to the 5th power. Okay, if that's u, do I need to find du dx or du d theta? U is a function of theta. So you're going to find d. Okay. Sneaky, sneaky. All right, let's go back. You got u, right? U is 4 minus tangent theta. That gives me what? Right? Why are we going to pick u being 4 minus tangent theta? Right? Isn't this about composition of functions? You got the inside function. It's between the parentheses. So I got u is 4 minus tangent theta. I need now du d theta because u is a function of theta. So I get du d theta to be minus secant squared theta. This is not dx. So we don't solve for dx. We solve for what? D theta. And what do you get? D theta is du over minus secant squared theta. So I'm going to go now replace my d theta with what? What do I replace this d theta with? Du over what? Minus secant squared theta. Okay? Does anybody notice, what does minus secant squared theta actually mean? That's negative 1 times secant squared theta. What cancels? Secant squared what? Theta. You guys notice how nice that works? Because these are all specially chosen. And what you end up then with is this integral now. Don't forget that's a constant. I pull out my negative constant. And this is really now u to the 5th d what? U. This is not d theta. I replaced my d theta with the du over minus secant squared theta. And then now, what do we get? Negative, what's this? U to the what? 6 over 6 plus my c. Is that true? Okay, maybe you said, do I really get this sort of thing? Yes, you do. Subtract or distribute your negative sign. That's minus c. Again, what do we generally say? We can call this, it's minus c. Give you every detail. You can say, is that plus a negative c? Yes. Do we call this C1? I guess so. What is u again? What is that? 4 minus tangent theta to what power? To the 6th power over 6 plus a what? Constant c. Anyway, yeah, you don't have to call this, C1 or anything. But yeah, really, this is every detail. Okay, because this is -1 times this integral. So you're going to have to find what that integral is. And yeah, that's -1. This is the answer. So when you distribute the negative sign, it's there. All right, you want to write it as plus the negative c. It really doesn't matter ultimately. It's just a constant. So there you go. Yes?
So does it matter if you put negative or positive c?
It not necessarily matters at all. But if you look at every calculus book, we're going to stick with what? Plus c. A constant could be positive, constant could be negative. A constant is just another way of saying a number. It's just a number. So yeah, we use default plus c. Okay, so anybody have any questions on this one? Like I said, when you have some practice with this, you could do this in your what? In your sleep. Now, let's go to the fun ones. See if we have time for the ones that were fun. Yeah, I don't even have my coffee even. I left it in my office. I hate those days. Can't even get coffee in me. Number 5. Okay, this one's actually an interesting problem. And what starts to happen, like I said, your skills are going to get better with U substitution. And, it gets pretty challenging at times. And, let's see what we can do with this challenge, right? So we got a couple of examples there that are a little challenging. What's today anyway? Is this Thursday or is it? It's Thursday. Okay. So remind me to talk about stuff a little bit. Okay. So after this challenge, we'll talk about a few things. What did we say you probably wanted to be? What do we want you to be? There's different ways to go about this. There's different ways. You might be able to do this in more than one way. Yeah, I just thought of another way. But anyway. What have we been saying you should be? The inside function in composition of functions? Right? What's inside in terms of a composition? This 1 minus x, right? So if we let u be 1 minus x, what we get now, we have to find du dx, right? So du dx is going to be, what is this? -1, or now solve for dx. Dx becomes du over -1, or really dx is minus what? Minus du. So this is going to be replaced with a minus du, while this is replaced with a u. So what happens? That's a constant, right? So I pull out my negative constant, and I have my x squared on top, and then I have my square root of u on bottom, and then what do I have? A du. I know that's negative du, but I already pulled out the negative sign. Oh, you don't want to do that? Okay, let's just say negative du. Pull out the what? Negative sign, and we get x squared over square root of u du. And then you say to me, but Mr. Judge, you promised me things are nice, and I would get what? Cancellation with this x squared. Where's my cancellation? It's not there. So sometimes what? It doesn't, they give you a problem this way. It doesn't, nothing, x squared doesn't go away. So the question is, what do we do if our x squared didn't go away? What do you really have? What's the only thing you can use? Go back over here. What is u anyway? Isn't u 1 minus x? So I'm gonna suggest something to you. Because you know u is 1 minus x. What do you need? X squared. More importantly, what do you really need? You need an integrand that is a function of u. This is a function of both x and u. 2 variables, not 1. So you need an integrand that's a function of only one variable, u, because we're integrating with respect to u. So what I'm saying is this suggests that if I solve for x, right, isn't x equal to 1 minus u? And then I need to probably what? Square this. I get x squared is 1 minus u squared. I can now replace this with what? 1 minus u to the what? To the second power. And then you may say to me, but then that gives me this integral here of 1 minus u to the second power over the square root of u du. And I'll say, yes, it does. Okay, it does. But then you might say, well, how do I integrate this? Well, I guess you should use probably what? What do you guys notice about this thing? If I expand 1 minus u to the second power, I get a nice polynomial, right? And if I divide every one of those terms by u to the 1/2, well then, I still get a, an expression in which I can use power rule for. Is that right? So that's what we're going to have to do. We're going to have to use a little bit of algebra. So our focus now here is going to become, can I erase this here? You guys have this in your notes? Because, we're limited with our board space. So I'm going to call this here, let's call this our work, or let's call it algebra. So by the algebra now, what do we get? Well, 1 minus u squared over square root of u is actually 1 minus 2u plus u squared if I expand. Is that right? We expand using FOIL. Okay? And isn't that u to the 1/2? So what happens now, this u to the 1/2 is dividing each term. So you get 1 over u to the 1/2 minus 2u over u to the 1/2 plus u squared over u to the 1/2. This becomes u to the minus 1/2 minus 2u to, this is 1, this is 1/2 to the 1/2 plus 2 minus 1/2. That's u to the what? 3/2. This is what my algebra does for me. So instead of integrating this, I can now integrate u to the minus 1/2 minus 2u to the positive 1/2 plus au to the 3/2, and that's now du. This is now a question from your previous homework, I guess. Using properties of integrals, meaning integrals of sum and difference is difference of sum and, integrals of a sum and difference is difference of, well, I can't say it that way. Integral of a sum is a sum of integrals. Integral of a difference is what? Difference of integrals, okay? Integral of a constant times a function, pull out your constant. So by properties, this is the integral of u to the minus 1/2 du minus 2 integral to the u to the 1/2 du plus the integral of u to the 3/2 du. I realize it's a bad place to put this all, but again, we're going to have to erase parts of the board. Do you guys have the algebra in your notes? You have this algebra? And we forgot the what? Negative. So yes, everything changes. So there's a negative here, right? Negative here. Negative here. Let's change it up here. Okay. So let's get rid of all this algebra here. Let's look at this. This, you can think of it this way. Well, we can say integral of that negative u to the what? Minus 1/2 du. Let's be careful here. Let's be careful. You're right. There's a negative here. Let's be very careful here. Let's see what's going on. That negative sign, we can do it one of two ways. I can keep that negative sign outside here. Put it in a bracket, okay? And now, see this negative sign that's here? And this has to be within a bracket because that negative sign is there. Okay? This is minus this integral of these functions. There is a negative sign here. So I can keep that negative sign, and I got u to the minus 1/2 du minus 2 integral u to the 1/2 du plus integral u to the 3/2 du. Okay? Double check. Do we have everything here? Okay. So we got that minus sign here. Okay? Now, again, if you don't like that, just distribute the minus sign to each integral. Okay? I might just keep it. Distribute at the end. So what is this? That u to the 1/2 over what? 1/2. Isn't this by power rule? Add 1. Minus 2u to the, what's 1/2 plus 1? 3/2. What's 3/2 plus 1? 5/2. Just say plus your c. This is going to be what? Final answer. 2 square root u minus 4/3 u to the 3/2 plus 2/5 u to the 5/2 plus your c. Okay, and then you can distribute this minus sign, so you get minus 2 square root of u plus 4/3 u to the 3/2 plus 2/5 u to the 5/2, and you say that's a minus c. I'm going to erase this. I'm going to keep my u as 1 minus x. And then it might be a good idea for us to do some what? Can you guys simplify these? What's u to the 3/2? Right? Isn't this minus 2 square root of u?
Isn't the 2/5 negative?
Plus 4/3. Is your 2/5 negative?
Yes.
Oh, change the sign. You're right. Where did we change that? Right here, negative. Okay, good. How do we simplify u to the 3/2? Isn't that u square root of u minus your 2/5? What is this? Anybody know what this is? Is that u squared, u to the 1/2? And do I have to put a minus c, or can I put a, okay, plus c1 maybe? So this is your answer in terms of what? U, but what in the world is u? This is 1 minus what? 1 minus x. So your final answer is going to be negative 2 square root 1 minus x plus 4/3 1 minus x square root 1 minus x minus 2/5 1 minus x squared square root 1 minus x plus my constant what? C. So let's double check our signs. Minus, plus, minus, minus, plus, minus. Okay, it looks okay to me, but I haven't had my coffee, so Anybody have any questions on this one? Get out of the way. Yeah. It doesn't matter if it's plus C or minus C, but you're going to look in every calculus book, and it'll be a plus what? Plus C. Yeah, every calculus book will have a plus C there. But technically, it doesn't even have to be a plus C. It's just by default we put plus a constant. It could be, like I said, and I know I called it C1 here, but like I said, after a while, you just simply call it what? Call it C. So this took a little bit of work. What about the next one? What do you think about the next one? What's the next one? Does that take work too? Should give you guys get started on the next one, or should we have our talk? We'll have our talk. Okay, let's try some extra U substitution then. And I'll answer some of those other questions you guys might have. So, integral x, what is this? 4x squared plus 3. Is that the third power? Okay, just to let you guys know, when you go to calculus 2, they'll expect you to do U substitution, know how to do. They won't even bother stop and explain it to you, because your main integration technique isn't what you had with the earlier chapters. It's actually U substitution. That's what you're going to see forever. So when I teach calculus 2, it's pretty. It can be pretty brutal if you're not up to date with U substitution, because then you really fall behind. So it's good that you guys are here doing this, Anyway, and I'll use the video for those who, like I said, if you came from another class for calculus 1 and they want to review U substitution, we'll have it all up for them. Okay, and we'll put this up for you guys too. But anyway, remember, what do you want U to be? This is based on composition of functions. So U is the inside function. Is that right? So what would you guys say U is here? What's the inside function in the sense? It'd be 4x squared plus 3. So you're going to let U be, right, 4x squared plus 3. And then again, what do? You differentiate U with respect to that variable, x. And this is going to be 8x. Right? So you're going to use this. Now remember, don't solve for du. Solve for what? Dx, because there's a dx here. So if I solve for dx, you guys know by cross multiplication, dx will be essentially, what is that? Du over what? Over 8x. Right? If you cross multiply. So you do your algebra, you can say this is du is 8x dx. Now divide both sides by the 8x, so that's where you get it from. Okay? In case you're wondering, how do we get that? With a lot of practice, you actually know what dx is, with a lot of practice. You could do this mentally even after a while. So anyway, this integral, if we replace now what? U with my 4x squared plus 3, there it's right here. I still have an x though, but this is now U to the third power, and then I replace dx with what? With a du over the what? Over the 8x. And what happens now is notice that you get your cancellation with the x. So then the question becomes, what does this information now mean to you, right? What does that mean? It means that you can, that 8 is a denominator for a fraction, maybe 1/8 if you want to think of it. But it's a constant. So what could you do with all the constants? You can pull out your constant. So it's going to be 1/8 integral U to the third du. Okay, you guys okay with that? And then what do you guys notice about this? This here is what you get to integrate, or find the antiderivative for using your power rule. Right? So the power rule here is going to be U to the fourth over 4 plus C. And what this then gives you is 1/8 times that U to the fourth over 4 plus C. And like we talked about before, you can multiply, both of these you're going to distribute that, and you get u to the fourth over 32 plus 1/8 c. You can call this just a, well, sometimes people say that's a different constant, so they put a subscript like 1. By now, you might think, well, you don't have to put a subscript. You know that it's just a constant, so you can say it's u to the fourth over 32, just plus your constant c. Now, what I want to say about this is, you know, when I actually grade this somehow, I think what I kind of try to look for, just so you guys know, is whether you got the right u, whether you got the right dx, whether you actually got the right, you know, integral here, and maybe whether you got this here. And then what I look for the final answer is, notice if you integrate this, this is a function of x, but your answer is in terms of u. So what do we need? We need to put back the u, since it's 4x squared plus 3. So this final answer is going to be 4x squared plus 3 to the fourth power. We resubstitute that over 32 plus c. And then this here is your final answer. So what I do when I grade this, this is kind of how I look at it in some ways. Does the person know the process of u substitution? So 1 check, 2 checks, 3 checks, 4 checks, maybe 5 checks. So it's 5 checks for one problem. So you get each check as you go through and do every step correctly. Yes?
Do we have to show how we distribute the constant to the c value?
No.
Can we just leave it as c?
No, you can just leave it as c. In fact, I just leave it as c. Yeah, I just do it as well. You know, as c, you guys can do it too. But what I want to point out to some people is that if you stop right here, then you only get pretty much what? You know, 3 checks out of the 5. So, you know, and sometimes I get so nuts, I might give it 1, 2, 3 checks. So if you stop right there, you only get, what, 1 check out of 3. Isn't that horrible? It's horrible. Okay, but the reason I do that is because you have to get used to completing the process. And a lot of people sometimes think, oh, that's just good enough. You're like, no, it's not good enough. You have to complete the process. Anyway, that's kind of what to expect on like a grading. Okay, anybody have any questions on this first one? No? Have you guys gotten use of a lot of this u substitution? Yeah, hopefully, like I said, you know, if you're going to take the summer off, which you might, I kind of, you know, recommend that over, you know, we already talked about that, but, you know, you want to get as much u substitution in u as you can. Let's try the second problem we have here. So we have x squared now over, is that 16? 16 minus x cubed squared dx. So what do you guys think the inside function is again? The 16 minus x cubed. Okay, so we're going to let u be 16 minus x cubed. Then differentiate u with respect to x. What's this going to give you? Minus 3x squared. Don't forget that's du dx. What do you solve for? Okay, then that gives you dx equals, you get du over a minus 3x squared. You get this? Yes?
I did it another way. I left it as dx squared. No, x squared dx equals negative 1, but negative 1 over 3 du. Is that okay?
Oh, well, hold on. You're saying x squared dx is...
Negative 1 over 3 times d. And it cancels out.
Well, it will. I think what you're doing is you're solving for x squared dx, right? You said, okay, I'm going to solve for x squared dx here. You're saying du minus 3x squared dx. You're just recognizing personally here. The x squared dx is x squared dx here. And then I understand you're going to say this is du over negative 3 is that x squared dx. And you recognize, again, this x squared dx goes up here. I mean, you could do that and replace this x squared dx with du over negative 3. You could do that. But like I said, personally, there's nothing wrong with that. That's fine. But I kind of personally try to go about it the same way. And I don't even think anymore. But yeah, you could do that. It's not a big deal. But if I do it, you know, how we've been looking at these problems, leaving that as x squared, this now becomes u what squared. Notice what my dx becomes. Isn't this du over minus 3x squared? And then what happens with your 3x squared? That's gone, and what's left? That constant, right? So you're going to have a minus 1/3 integral 1 over u squared du. I pull out my constant, and then that's minus 1/3 integral u to the minus 2 du. Okay? You say, well, why would you put 1 over u squared as a negative power? Do you guys know why? Because we're going to use power rule. Okay, you guys okay with that? So we're going to have to integrate this. What I'll do, just like you in some ways, is to simply say, well, what's the integral of this? You guys know? Isn't that u to the negative 1 over negative 1 plus your c? Is that right? Don't I add 1 to negative 2 to get negative 1? Then I divide by that negative 1. Really, you're going to use your distributive property. Now, this is negative times negative, which is what? Isn't that 1 over really 3u? And I'll just put plus the c like you just mentioned. Can I just put a constant there? And the answer is yes. Right? And then what do you replace u with? You guys know? What is u going to be? 16 minus x cubed plus c. And there you go. So like I said, I might do something like this. 1, 2, 3, 4, 5. That's kind of how I might look at that when I grade it. So you have to go through every step correctly. Okay, you guys okay with that one? Anybody have any questions on number 2? Okay, let's erase this. And then number 3, I have the integral tangent to the 4th power x secant squared x dx. I'm going to let u be tangent. Okay, I'm sorry, I shouldn't have told you guys. I should have asked you guys. Let's not pretend we didn't see tangent. What would you let you? What do you want u to be? Why do you guys think? I mean, why would it be tangent? Because when you see the secant squared, you guys know the derivative of tangent's what? Secant squared. It's no coincidence that you got a tangent here. Now this is tangent to the 4th power, right? So what this is, when you see tangent to the 4th power, is really, this is tangent to the 4th power. Okay, that's the same thing. So as you guys can see, tangent is your inside function for composition. And so that means u will be tangent x here. Now it makes a lot of sense now that we have secant squared, because du dx is actually secant squared x. So you go, oh, okay, I see that. And again, what I'll do is solve for dx, which means my du is secant squared x. Now, if I replace this with u, I know really, and I'm going to have my secant squared x, I got dx here. So this integral becomes u to the 4th secant squared x times du over secant squared x. And the secant squared x's go away. So this integral is simply u to the 4th du. Okay, again, power rule. I get 1/5 u to the 5th plus c. And then finally, what is u again? Tangent. So this is 1/5 tangent to the 5th power x plus your constant c. Okay, let's close the door. So anybody have any questions on number 3? No? You sure number 3 is okay? Look at yes.
So for these type of problems, you just kind of like work it on in your head, sort of, so you get something that's going to cancel the other one, like the secant squared in this case. How you automatically chose tangent because.
Well, two things. Personally, again, remember, U substitution is based on composition of functions, right? It's almost chain rule for integration. So when you let U be a function here, you got some choices. I mean, you could let U be secant, let U be secant squared, but when you find your du, you know, when you differentiate U with respect to x, you're going to get, you know, some answer, some function of x. Now, when you go through the process, you're going to replace one of those things with U. So the question is, what do you replace it with? What do you replace it with so that we get a nice cancellation? Meaning that your integral now is essentially what you see here in terms of U. There's no x. We've been talking about this idea of an inside function. Your inside function, if you remember correctly, this is f of g of what? Of x. This is composition. This is the inside function. So, you know, when you work with composition of functions, this was a function and a function. When I look at this, in all honesty, I see an inside function here. Here's in some ways you can call, you know, your function f to be x to the 4th. We can call the function g to be actually tangent, so that when I take the composition of f with g, I'm really doing what? What's the inside function now? It's tangent, right? So I'm looking at the function f. What does f do to every input? What does f do to this input function? Well, it just does what? It raises it to the 4th power. So this is tangent x to the 4th. So in some ways, I actually just simply go back to my composition of functions, and I notice that within my parentheses to the 4th power, if I let u be tangent, what's the derivative? It's secant squared. So you're going to have that cancellation. That's what we're doing really with all of them. You're identifying really here, and you guys hear me talk about this inside idea, because that was the same inside function when you guys had chain rule. Right? It's the exact same inside function, or input function, I should really say. So this is based on compositions and finding what was that inside or input function, knowing what f and g was. So that's what it's based on, and that's kind of what I do. I don't know what other people might do. You might tinker with it, but I think a lot of us at this point, we kind of look at it that way because we've been talking about it that way. You're looking for that input function. Okay, so what about the next one, number 4? I'm sorry, but does anybody have any other questions on that? Is that, you okay with that? What's the inside function for the next problem, right? Right, you have this next problem here, right? Number 4, we had to integrate, and this is actually something you guys already did. But I wanted to show you with U substitution. You already did this on your homework. Okay, but let's go back and think of this what? Composition business, right? This composition, the inside function, and that maybe even the outside function, or your input function, right? So in this example, inside function is going to be here. What do you want U to be? You want U to be what? 2x? Is that true? Is this your U? Okay. Then once I have U, what do I have to find? What's du dx? What is that? Is that 2? Okay, and then what do you solve for? Dx, and what do you get for dx? You get du over 2. So let's now substitute. This is U what? Substitution. You guys get square root of u, and then what is dx? Is that du over 2? If I replace my dx with du over 2, I'm using my u, I'm using my dx. What happens with the 2? It's a constant that comes out, and then you have u to the what? 1/2 du. Now, notice, didn't we get rid of here? Isn't this just an integral with respect to the variable u? Okay, so if we got to this point where it's something that we can do, it looks like maybe we're on the right track, right? What do you guys get now with this? Now apply your what? Apply the power rule. What is the antiderivative of u to the 1/2? So u to the 3/2 divided by what? 3/2 plus c. Now this is 1/2 again, and this becomes, if ever I take a whole number divided by a fraction, right? That'll be 2/3 u to the 3/2 plus your c. Use your distributive property. 1/3 u to the 3/2 plus, again, our constant. We're almost done. We just have to know what u is, right? What is u anyway? Okay, so this is 1/3. Now, 2x to the 3/2 power plus c. Does anybody know, can you simplify that in any way? Right, because what does this actually mean again? Right, it's 1/3, maybe 2x to the 3rd power under a what? A radical, where the index here is 2, because you're dealing with the square root. You see that 2 and that 2, right? What do you think happens now? You get 1/3 times 2x times square root of what? 2x plus c. And so if you're looking back at the book, you might see 2/3 x square root 2x plus c. Yes?
So if you stop right there where you just put 1/3 2x 3/2
So, where right here?
yeah, if you just leave it like that.
You might get 1, 2, where's that? 3, 4 out of what? 5 checks. Yeah, you want to go all the way if you can. And it's not too bad. It's just simplifying a what? Radical. See, what happens sometimes is when students they get all the way up to here. And then they're looking back at the book, and then they look at this, and they go, oh, I did everything what? Wrong. See what I'm saying? They question everything that they've done. So when you just write up to here without doing what? The simplification, you run into that territory of not knowing the difference. And that's, it might be that you're perfectly fine, and then you might spend how long sweating that kind of thing? 45 minutes, whatever, an hour, and you pull your hair out. When all reality is they just simplified it. So, it is important to simplify. And anyway, any questions on number 4? Yeah.
So would it be wrong if it was 2x 3/2 over 3 plus c?
Say that again.
2x to the 3/2 over 3.
2x to the, you mean this?
Yeah.
The question that was just asked?
Yeah.
That one? I would only give you personally what? How many checks is that? 4 out of 5. That's how I would look at it. Again, why do you want to go all the way if you just leave it like that? Anybody remember? What was the answer? Why do you go all the way? Why do you want to simplify your answer? Does that have any benefit, you guys think? Has a lot of benefit. So that's why you want to go through and, yeah, you want to go all the way. This is number 4. All right. Did you guys anybody get to number 5? You got to number 5. Did you like number 5? No? I think number 5 was, they're not too bad, I think. What do we have for number 5? Number 5, you have what? 1 over x squared. Let me know when that turns off, right? It goes off every like half hour or so. All right, thank you. We're okay. Number 5, we got 1 over x squared you got sine of 1 over x, that's dx. So let's see. What do you think that inside function is going to be? Okay, good. So you're going to let u be 1 over x. What comes next? Right, isn't that x to the minus first power? So what's du dx? Minus x to the minus 2 minus 1 over x squared. Is that right? So what does dx give you? Is that negative x squared du? So you're going to use this. You're going to use this. And then, right, you have the 1 over x squared here. I got sine now u. What's dx going to be? That's the negative x squared du. So what do you guys think is going to happen now? What goes away? Good, your x squareds go away. Now don't forget, that's a negative, which means there's a negative 1 constant here I can pull out. So this gives me actually negative sine u du. So notice again, this is a nice function of u. So we got to think, what's the antiderivative of sine? It's negative cosine. I already have a negative. So isn't that minus cosine u plus my c here? And then minus and minus makes this what? Plus. And then I'm going to keep this plus u, or plus c. Even though I know it's negative, it's just a different c. Okay, it's a different c. So this is cosine u. But what is u? Is that 1 over x? And there you guys go. Here's another, here's another answer. So cosine 1 over x plus c. So like I said, when I read this, I look for this. I look for this. What else do I look for? Oh, this, and then this. So I look for those pretty much 5 things personally. Okay, anybody have any questions on number 5? All right, you sure these are too easy? Huh? Oh, maybe we should have just slept in today then if these are all too easy. It's all too simple. Should just sleep in. 6. 1 plus 1 over x to the 5th power. And then what's that times? Do you guys know?
1 over x squared.
Times 1 over x squared dx. Okay, what do you guys want u to be? It's going to be 1 plus 1 over x. Is that right? Now don't forget that's 1 plus x to the minus first power because I need a du dx. All right? So what is du dx? I have to differentiate that. That's minus x to the minus 2 power. Is that right? Which is negative 1 over x squared. So how do you solve for dx? I think that's negative x squared du. Is that right? So I'm going to use this. I'm going to use this. Double check. So it looks like I have integral u to the 5th times 1 over x squared. And then my dx is a negative x squared du. My x squareds go away. I have that constant negative 1 again. So what happens with that negative 1? That's negative u to the 5th what? Du. So how do you guys integrate by power rule here for antiderivatives? It's 1/6 u to the 6 plus your c. So you get negative 1/6. What was u again? 1 plus 1 over x to the 6th power plus your c. So here you guys go. Okay, you guys okay with this one? Sure? All right, let's see. Number 7, I get, what is that, cosecant? Let's look at number 7. We got cosecant squared, is that 1/2 x minus 5 dx? So these are all questions from another calculus book, just so you guys know. What I did was I went and I looked at another calculus book I had at home. I went up, looked up U substitution. I just took some of these questions from that book. So anyway, so this is a calculus, book that. Okay, this is actually a very good book. Anyway, if U is going to be 1/2 x to the minus 5th power, we get du dx. Du dx is 1/2, and then we get dx to be 2 du. So notice our integral is going to be what? Cosecant squared u, where dx is times 2 du. My 2 is a constant I get to pull out. So 2 integral cosecant squared u du. Does anybody know how to integrate cosecant squared? What is it? Let's note. All right, I know that if I differentiate what? The cotangent curve, what do I get? Negative cosecant, right? So I get negative cosecant squared. Sorry, negative. No, I'm sorry, I got that right. Differentiate cotangent, what is it? Negative cosecant. And it's to the 2nd power. So, in other words, what this means is really that the derivative of minus cotangent is actually cosecant squared. Is that right? Okay, so if I differentiate negative cotangent, I get cosecant. So, why am I thinking of this? Do you guys know why you think about that? Because if you want to find the antiderivative of cosecant squared, antiderivative of this function, what is it going to be? This function. So this is going to be here a negative 2 cotangent x plus, cotangent u plus your c. You get to replace this with a minus cotangent u plus c. Okay, yes, 2 gets multiplied to both terms, and that's why I put the negative 2 here, because that's negative. 2 times that constant, I could just call it a constant. We're practically done, because what is u going to be? What was u to begin with? 1/2 x minus 5. This will be plus my c. And there you go. Yes?
Do you mind doing one of the ones that cancel on the book? It says because it's odd number or it's
We'll talk about those. Yeah. Okay, you guys okay with that? Anybody have any questions on this one? All right, let's look at number 8 here. Okay, so what do you guys think? What's your inside function going to be? What's u going to be? X plus 2? Okay. Then what is du dx? Is that 1? That means dx is du. Is that true? So I have here the integral of x squared cube root really of u, and then my dx is du. And what do I do now? Oh no. What do I do now? My x squared didn't go away. Aren't I supposed to have just a function of u?
Your u equals x plus 2, you can solve for x.
Huh?
You can solve for x and square it.
Solve for x and square it. Is that a good idea?
Yeah.
Okay, it's pretty good. Sounds like you guys had a weekend of u substitution. Good for you. You guys must like yourself. Good. Okay, that's u minus 2 is x. And then if we square both sides, I get u minus 2 squared is x squared. Is that right? And then I'm going to say to you guys, let's go further. What is u minus 2 to the second power? I mean, because what you're going to say now really is this. You're going to say, I'm going to replace my x squared now with a u minus 2 to the second power times that cube root du. This is a nice function of u now. Okay, I replace my x squared with what it is. The only problem is, how do you integrate something like this? There's a couple of ways I can think of it. Well, maybe not, but anyway. One thing I want to think of is what you guys did when you first started learning about antiderivatives. When you first started learning about definite and indefinite integrals. If you guys remember the homework you guys did there, you didn't have any u substitution. All you guys had was algebra, your algebra skills. So what I mean by that is you're going to replace this by using FOIL. You're going to replace this with what it's equivalent to. You're going to expand that. And if you expand that, I'll put that as a note here. Let's put some algebra notes here. So let's note that if I expand u minus 2 squared by FOIL, really, don't you replace that with simply u squared minus what? Minus 4u plus 4. Isn't that what you get by FOIL? Now, don't forget that if I take u minus 2 squared and I multiply it by u to the 1/3 power, then that's going to be my u squared minus 4u plus 4 multiplied by u to the 1/3 power, right? By algebra. What happens when I distribute this u to the 1/3 power to each term by the distributive property? Right? Don't you end up with, I'll put it here, u squared times u to the 1/3. Is that what? That's going to be 6/3 plus 1/3, 7/3 minus 4. This is u to the 1 power. Add my 1 with 1/3. Don't I get what? 4/3. That's plus 4u to the 1/3. Because it's a constant times u to the 1/3. So anyway, this problem becomes the integral of u to the 7/3 minus 4u to the 4/3 plus 4u to the what? 1/3. And then that's going to be du. You know. So I have 3 integrals here. Anyway, now let's find the antiderivative of each one of these by power rule. So this is u to the 7/3 plus 1. That's 10/3 over what? 10/3 minus 4u to the 4/3 plus 1. That's 7/3 over 7/3 plus 4u to the 4/3, good, over what? 4/3 plus my c. Now, whole number divided by a fraction again, you get 3 over 10, u to the 10/3 minus, isn't that 3 times 4? 12 over 7, u to the 7/3 plus, 4 times 3/4, right? What's 4 times 3/4? That'll be plus 3 u to the 4/3 plus your c. Okay, now this is in terms of u. Can I erase the algebra? You guys have that? Okay, erase the algebra. I'll get out of the way. Okay, we're not done. Well, we can if you wanted. You guys want to simplify now? What do you guys think? Should we simplify that? Can I erase this though? Okay, let's erase this. You guys have this in your notes? The issue is, should we simplify this? We could. How do you guys know how to, how about this? How do you guys know how to write this in simplified form? What is 10/3 really? If I divide 10 with 3, what's the quotient? 3. What's the remainder? 1. So this first answer in terms of u, we can say is 3/10 u to what power? 3 cube root of 3. Right? Minus 12/7. Let's do this again. 7 divided by 3, what's the quotient? 2. What's the remainder? Is that 1? So I could write this as u squared, u to the 1/3 power. Now, what's 4 divided by 3? What's your quotient? 1. What's the remainder? 1. So I can say plus 3u, u to the 1/3 power, plus your c here. And, you know, if I like, that's, I mean, I can factor out maybe a u, but, you know, at this point, we can just put what? What is u anyway? X plus 2. So it'd be x plus 2 cubed, cube root, x plus 2, minus 12/7, x plus 2 squared, cube root, x plus 2, plus 3, x plus 2, cube root, x plus 2. I'm going to erase this here. And then I guess we have our what? Constant, right? So here's your final answer. Double check we didn't make any mistake anywhere here.
So you would actually take points if we just leave it as before.
Absolutely. Why? When your mom tells you to clean your room, you don't hide your socks under the bed. Is that right? Exactly. I would take points off with pleasure without simplifying. I'd say, oh, absolutely. 1, 2. What am I looking for? Yeah, maybe 3. This might even be worth more checks. The person do the algebra. You get your answer. And then what? Yeah, the idea is to motivate you to complete the task, which is, ironically, for some people, is like pulling teeth. The reason I say that is because when I've graded tests, very often students stop right here or over here and will expect pretty much full credit. They go, well, you know, I'm here. And it's like, well, no. So the reason I insist on going all the way is so that those people who have the false intention, it's almost like they kind of like, they're just programmed that way. You know, they'll stop right here and think that that's good enough, right? But it's really not nowhere near good enough, actually. It's nowhere near what you got to do. I mean, what if you turned it into a nice what? What if you applied some limits? You know, so you're going to need to go all the way when you apply the limits even. But anyway, so that's number 8. Whew. Yes.
If you apply the limits, but if you did it like in regards to u, or those limits and you send from u, would you have to go all the way to the x?
No, you don't. You could actually convert them. Yeah, you can convert them to u to do it here. You could, but then you still probably have to simplify. You know. Maybe not. I mean, sometimes you get nice and lucky because they choose nice, beautiful limit values, right? Like 0 and 1 is beautiful. I'm not sure. Well, was it going to be nice if this is 0? Oh, well, u will be 2. 1, u will be 3. So yeah, you might have some simplification definitely to do, even if it's in terms of u. So what some of these questions become, like I said, people's biggest issue isn't going to be necessarily finding a what? Antiderivative by power rule. It's always going to be some algebra or arithmetic, you know, some past problem, you know. But yeah, absolutely. You know, if you tell somebody, hey, you can't use power rule with u to the 1/3. Yeah, people can kind of do that, but that's not all you have to do for these problems. You know, it's not all it is. There's much more. So okay, anybody have any questions on this one here? Nope. Number 9. What is that? Number 9. It's the integral of, what is this? 1 over square root of x. Is that 1 plus the square root of x? Is that what it is?
Yeah, squared.
Oh, and then squared. Okay. Dx. So what do you think the inside function is going to be here? What's that u? Huh? Is that 1 plus the square root of x? And that's be 1 plus what? X to the 1/2. And then now you also have du dx, which will be, yeah, what's this? 1 over 2 square root of x. Remember I said this one shows up a lot, right? So if I solve for dx, isn't that what? 2 square root of x du. Integral 1 over square root of x, and that's going to be, I guess, u squared. And what's dx? 2 square root of x dx. Oh, sorry. du. So your square root of x's cancel. And then you got 2. Pull out the constant 2. U to the minus 2 power du now, right? That's 1 over u squared. So if I'm going to cancel and bring out the constant 2, then it's u to the minus 2 power. Whew. Okay, you guys okay with this? And so what do you guys do with this now? Right, integrate by the power rule. So that'll be u to the minus 1 over minus 1 plus c. What's this going to be? If I distribute this even, I think this is going to be negative 2 over what? U plus your c. Right? Because u to the minus first power means put me on the bottom. The negative, put it out here. So it's negative 2. And then u is 1 plus the square root of x plus your c. Beautiful. It's beautiful. Question?
Can I simplify it any further?
Can you simplify that any further? No, you're done.
Multiply by the conjugate.
Don't have to. Don't have to. Yeah, I guess you know if you want to rationalize or do not, it's okay. Anyway, this is these are some more examples of u substitution. What you guys want? Anybody have any questions on this one? Huh? Okay. Maybe we'll.